In this lecture, we're going to see that we can set up our loops to go in the decrementing direction, if I may say it like that. Here on the top, we have a loop that is going to loop for 5 times. It's going to start from 0. It's going to go until I is no longer less than 5, and it's going to keep printing I. So here it's going to print from 0 all the way to 5, and that's going to be 5 times. This loop is going to loop 5 times. If we go down here, we're going to do a version that is going to increment, and it is not going to start from 0. It's going to start from count, so it's going to start from 5, and the test is going to be to test if I is greater than 0. And as long as this evaluates to true, the loop is going to keep running, so we're going to fall in the body, we're going to print whatever value we have in I, and then we're going to decrement, and this is going to repeat until we hit the point where this condition here fails. And we are basically going to print 5, 4, 3, 2, and 1. And once we hit 1 and decrement, this is going to become 0, and it's no longer going to be greater than 0, and this loop is going to end. This is how you may set up a decrementing loop. And the technique is really to set up a big starting point, and then you're going to be decrementing until you hit the point where you want to stop the loop. It is really nothing special, but I just wanted you to be aware of this. And one thing you should know is that ranged-based for loops can't be set up to do decrementing like we were doing with our for loop, because we have gave up control of the things we can use to make this loop do whatever it is we want to do. So we don't have access to the iterator. We can't do the incrementation. We can't really control this loop and make it do whatever we want because we have given up that control to the compiler. So the compiler is going to do things in a way that we're going to be able to grab the value and print it out in the body, but we don't have enough control to be able to make it print things in the reverse order, for example. With while loop, we can do that because we have access to all these things. We have access to the iterator, we have an incrementation part, and we have a test part, and we can really make it go in reverse order, just like we did with our for loop. So here on top, we have an incrementing version of our while loop. Again, it is what we have seen before. We're going to set up an iterator. We're going to say while and put in our test. And the test is going to check if I is less than count, and it is going to keep printing until this test here fails. So it is basically going to print from 0 all the way to count minus 1. We can do a decrementing version of this, and again, the technique is going to be the same. We're going to be starting from a slightly larger number, so we're going to start from count. We're going to test and see if I is greater than 0. So it's going to count from count all the way to 1. And then we're going to do our decrementation here. And then we're going to print our number and do the decrementation here. And if we run this, again, it's going to print from count and go all the way to 1. And that's when it's going to stop, because once we hit 1, the test here is going to succeed because 1 is greater than 0. We're going to go inside and print a 1, and then we're going to do the decrementation. And the decrementation is going to give us a 0. When the loop evaluates next, 0 is not greater than 0, so this is going to be false, and the loop is going to end. I hope this makes sense. We can do the same thing with the do while loop. It is basically the same thing. We have an incrementing version which is going to go from 0 all the way to count minus 1, and we have a decrementing version which is going to go from count all the way to 1, and it is the same thing. We are just setting up in a way that it's going to use a do while loop. One thing you need to be careful about with these decrementing loops is if you are trying to also print 0. So one might attempt to do something like this, and it looks like it is an innocent loop. It is going to do decrementation, and it is going to go from count all the way to 1 like we have seen. But that's not what's going to happen. This is going to be an infinite loop, and try to guess why. And to understand this, let's suppose we have a 1 in here. Let's suppose count is 1. So when we try to run this loop here, we're going to say for size I, we're going to put in a 1. We're going to test and see if 1 is greater or equal to 0. This is going to be true. So we're going to fall inside the loop. We're going to print a 1, and then we're going to decrement. When we decrement the 1, we're going to get a 0, and we're going to try and evaluate again. If we go again in here, I is going to be 0. The test here is going to be successful because 0 is greater or equal to 0. So we're going to go inside and print 0. And we're going to decrement 0, and we hope to get a -1. But the problem is, size t is an unsigned type, so it can't store a negative number really. So what we're going to get is an underflow, and it's going to flip to a really large number. And this test here is going to keep succeeding because it's going to start decrementing from 4 billion, for example, and it's going to keep repeating the same cycle, printing indefinitely. So this is something you need to be aware of. And the key is where we're trying to decrement from 0, hoping to get a -1, but that's not what we're going to get. We're going to get a large number, and this is a simple example that is going to show you that that's the case. So be aware of this. So I really want you to be aware of this problem and avoid it in any case where you are working with decrementing loops. Now that we have this explained, and I hope you really understand it, we're going to hop over to Visual Studio Code and actually try this out. Okay, here we are in our working folder. We're going to go in the current chapter, and the current project is Decrementing Loops. We're going to grab our template files and put those in our current project. And we are going to open this in Visual Studio Code. So let's do that. We're going to open Decrementing Loops, and we are going to open our main CPP file and remove whatever we don't need in this template project here. And we are going to put in the code to play with for loops. We're going to go down here and put it in place. We have a variable which is going to control the count, and we are basically going to print from 0 all the way to 4 because this is an incrementing loop. This is what we've been doing all along. But if you look down here, we're going to do a decrementing loop. And the way we're going to do that, our iterator is going to start initialized with a really big value. So this is going to be a 5 in this case. The test is going to test if it is greater than 0. And our incrementation part is going to decrement. It's not going to increment. And what this is going to do, let's actually try and go through this. We have a 5 in here. So if we go in here, I is a 5. 5 is greater than 0, so this is going to work fine. The test is going to be successful, and we're going to fall in here and print a 5. We're going then to do the decrementation here, and we're going to get a 4. The loop is going to try and run again with I equal to 4. 4 is greater than 0, so the test is going to be successful. We're going to fall in here and print a 4, and we're going to decrement that, and we're going to get a 3, and the loop is going to run again with a 3. 3 is greater than 0, so we're going to succeed and fall in here and print a 3. We're going to decrement. We're going to get a 2. The loop is going to run again with a 2. 2 is greater than 0. We're going to print a 2, and we're going to decrement again, and we're going to get a 1. The loop is going to run again with a 1, and 1 is greater than 0, so we're going to fall in here and print a 1. If we decrement, we're going to get a 0. The loop is going to try to run with a 0, and the test is going to say is 0 greater than 0, and this is going to fail, and the loop is going to stop, and we're going to fall at the end of the loop. So we're going to print from 5 all the way to 1, and that's the output we're going to get here. Let's try and run this. So we're going to open a terminal window here, and we're going to try and build this with GCC. The build is going to go through, and if we clear and run Rooster, we're going to see incrementing loop is going to go from 0 all the way to 4. The decrementing loop is going to go from 5 all the way to 1. And this is how these things work. And one thing we have seen is that we can't really control how a range-based for loop does its thing. Because we don't have control over the iterator here, the test condition, and the incrementation part, so we can't really change how it works. But that's really by design, because what you really want when you use a range-based for loop is to get the values from the container, and you usually want to go in incrementing order. And if you don't want that, you can loop yourself and set up your own things like this using for loops. It is going to work, but you can't make a range-based for loop work in reverse order like we just did for this loop here. So let's say that, okay, so this is something you need to keep in mind. Okay, now that we have this behind us, we're going to try and do the same thing we just did with for with a while loop. Let's comment this out so that we don't have a lot of noise output in our console. We're going to comment this out. The comment here is going to work. And we're going to go down and say while loop, because that's what we want to play with now. And we're going to put in the code. Okay, you notice here we have a squiggly line saying the count variable is not defined because we commented it out here. So let's take it and put it in front of our comment here. I think this is going to work. And put it in place like this. And if we go down, the program is going to work as expected. So we have an incrementing while loop. And it is exactly what we have seen before, so I don't think this really needs much explaining. But the decrementing version works exactly like we had in the for loop. We are going to initialize our iterator with our count value here. So it's going to be initialized to 5 in this case. The test is going to test if I is greater than 0. We're going to fall in the loop here. We're going to print whatever we want to print, and then we are going to decrement. So again, if we go through this, we're going to start with a 5 in here. The test is going to be successful because 5 is greater than 0. So we're going to go in here and print a 5. And then we're going to decrement to get a 4. The loop is going to run again. It's going to say 4 is greater than 0. That's going to be true because 4 is greater than 0. We're going to fall in here, print a 4, and we're going to decrement to get a 3. The loop is going to run again with a 3. So 3 greater than 0, that's a true. We're going to go in and print 3. We're going to decrement. The loop is going to run again with a 3. 3 is greater than 0, so we're going to print a 3 and decrement to get a 2. The loop is going to run with a 2. 2 is greater than 0. That's going to be true. We're going to fall in here a print a 2. We're going to decrement to get a 1. The loop is going to run with a 1. So 1 is greater than 0. We're going to print a 1. And if we decrement this, we're going to get a 0. When the loop runs again, it's going to say 0 is greater than 0. That's not true. So the loop is going to fail and fall at the end here. And we are going to print from 5 all the way to 1, just like we did with our for loop on top here. We can try and build this with GCC. And we're going to hit enter and clear and run rooster. We're going to get exactly the same thing, but now we are doing this with a while loop. We are going to comment this out here and do the same version with a do while loop because I want you to see these things. We're going to go down and say do while loop, and we are going to go down and put in our code. The incrementing version is what you have seen before. Okay, so size t has been commented out, and I don't really want to bring it outside here. It would be ugly for this piece of code. So I am going to go down here and actually declare it again. We're going to say size t I equals 0. And this is going to start from 0 and print all the way to 4. It's going to print 5 times because we are testing if I is less than count. So this is going to increment from 0 all the way to 4 again. But the decrementing version is really what we want to play with in this lecture. So we're going to go through this again. Let's go down again. It is going to start from 5. And it is going to go inside and print a 5. We're going to decrement. And we're going to get a 4. So the test is going to be 4 greater than 0. This is going to succeed. So the loop is going to keep working. We're going to go inside and print our 4. We're going to decrement, get a 3. 3 is greater than 0. This is going to be true. We're going to go inside again and print our 3. We're going to decrement and get a 2. The test is going to say 2 is greater than 0. This is going to be true. We're going to go in again and print 2. We're going to decrement and get a 1. The test is going to say is 1 greater than 0. The test is going to be true. And we're going to fall in and print a 1. We're going to decrement and get a 0. And the test is going to test if 0 is greater than 0. And this is going to be false. And the loop is going to terminate here because this test here has failed. And we are basically going to print from 5 all the way to 4. If we build this, we're going to be successful with GCC. We can clear this again and run rooster, and we're going to get exactly the same thing. Okay, before I let you go, I want you to see this kind of problem here. We're going to head over to Visual Studio Code and see that you can actually get an infinite loop if you are not careful. So we're going to use this code here, and to really focus on the decrementing version of this, we're going to comment out the incrementing version, or we can comment out the entire thing and do that in its separate section here, because we don't want to be confusing you when you come and use this code here as a reference. So we're going to come down here and comment out the entire section on do while. And we're going to go down and say infinite loop. And we're going to put in the code. It is going to be decrementing. And before we run this code, we're going to go through it together again. So we're going to start with I equal 5. We're going to fall in here a print of 5. We're going to decrement get a 4. 4 is greater or equal to 0. This is going to be true. We're going to fall back in our loop and print a 4. We decrement, we get a 3. The test is going to be true because 3 is greater than 0. And we're going to fall in again and print our 3. We're going to decrement, get a 2. The test is going to be true because 2 is greater or equal than 0. So we're going to fall in again and print our 2. We're going to decrement and get a 1. The test is going to be successful because 1 is greater or equal to 0. So we're going to fall in here and print our 1. What is going to happen? We're going to decrement our 1 and get to 0. This test is going to test 0 greater or equal to 0. And we're going to get a true because that's true. We're going to fall in here and print a 0. And if we decrement our 0, we're going to not get a -1 because size t can't really store negative values. So we're going to get an underflow and get a really large number, which is 4 billion something. So if we test again, we're not going to stop the loop. So if we go on and do the test again, this is going to be true because I is going to be 4 billion now. It's going to be greater or equal to 0. And the loop is going to keep going and never stop. We're going to try this out. So we're going to compile the program. We're going to build with GCC. And the build is going to be good. You're going to think, my program is going to work. But if you run it, you're going to see that it's never going to stop. It's going to be printing really large numbers. And this is not what you expect. So be careful about this. What is happening here is you are getting an underflow, and these kind of problems are really hard to debug and find. So the problem is that we are decrementing from a 0, hoping to get a -1, but that's not what we are getting because size t can't really store negative numbers. So if you change this, for example, to int can store negative numbers, so this is going to work. Let's try and build this again, and we're going to clear and run rooster. You're going to see that this is what we expect. But if we change this to unsigned int and build again with GCC and clear, again unsigned int, it is unsigned, so it can only store positive numbers. If you try to store a negative number in it, we're going to get an underflow. So if we get to 0 and try to decrement it, hoping to get a -1 so that our loop ends, we're not going to get a -1. We're going to get a really large number. And our program is definitely going to be running indefinitely. And this is what we get here. So be super careful about this. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. The next one, we're going to learn about nested loops. Go ahead and finish up here and meet me there.